Okay, problem 13. It's an integration problem. There's limits of integration over here, and they're asking me to evaluate this. All right, so just to quickly go through what we've done in the past, which is at the whiteboard, we worked on the problem. All right, now granted, these are things you may not be familiar with, and even if you are familiar, you might forget these things, and that's fine. I forget a lot of things too. But anyway, I went through this. You may want you may want to look these things up, but they're written down for you. And we went through that, and we finally, you know, arrived at an answer. So what I want to claim over here is, always arriving at an answer, you wonder, did I make a mistake somewhere? So what I'm going to do now is just simply look at Sage and see how Sage handles the problem. I'm going to open my terminal. I'm going to launch Sage. It's an application running on my computer. I'm going to reset. Basically gives me a clean sheet of paper. Define a variable x, which is a good idea. And now what I'm going to do is I'm going to type in the integrand. Well, I'm going to copy paste it, but I will go through over where this is coming from in the notes. Okay, let me go back over this. What I just typed in over here is the integrand, which is the square root of the sine x divided by this sum, which is the square root of sine x plus square root of cosine x. All right, let's go back to our Sage code. And what I'm going to do is integrate now. And we're going to integrate from 0 to 2 pi. And what happens, Sage is, I'm not going to say struggling, but it seems to not know what to do with it. And what it's doing now is, I guess it went through some rigmarole and it said, gee, I wonder what this is. And it got this over here, which is basically saying, gee, you asked me the same thing. I'm going to ask you the same thing. And it did. It just responded to me. So I'm going to go to another technique called numerical integral. And I'll type that in. Now, numerical integral is going to be a numerical process. I'm not sure what algorithms they're using, but if you've taken a course in calculus, particularly Calc 2, they go through a variety of numerical techniques like midpoint rule, right endpoint, left endpoint, trapezoid rule, Simpson's rule. All right? But anyway, what do you get over here? You get a number. All right, now the number I got is this number over here. All right, there is some error bound on it. I'm not worried about that. What I'm worried about is, does this number align with the number that we're saying? So what I want to type in is pi. The number I got is pi over 4. I'm going to approximate pi by using an operator. A function called dot n. That's the function calls n. So it's going to give me a numerical approximation. That's an abbreviation for numerical approximation. And I'll divide by 4. See what happens? And what do you get? You're getting this number here, which is remarkably close to this number over here. All right, so it's in line. I also want to claim, though, a lot of times when I'm doing work over here, I'm kind of curious if you open up an AI product. Now, I'm working at a school, and unfortunately at the school, they're going to block this. But I've got to say over here, the typical I do, if I'm at home, let me go back to, I have to open a web browser, sorry. And I would recommend, if you're not being blocked from using an OpenAI, to go to OpenAI. But unfortunately, I'm being blocked. I can't correct that. All right. So, again, we check this. Numerically, we got an answer of pi over 4. And Sage couldn't do the integration, but I approximated it. And I get approximately this number over here. So I'm good to go. Thank you.